Hello, I'm Amashni. In this lesson, we'll be dealing with equations that involve fractions. Now, when we are working with fractions, we also find the lowest common denominator. By the end of this lesson, you should be able to solve equations with fractions and find the lowest common denominator of simple fractions. Let's start by looking at the following example. Maria needs to reach the train station on time to catch a train to work. The station is 6 kilometers away from her home. She walks part of the way at 5 kilometers per hour and then she realizes she is late. So she runs the rest of the distance at 10 kilometers per hour. In total, she moves for 48 minutes. Determine how far she ran. We start by deciding what the unknown is. The question usually gives us a clue. Look at the information. How far did she run? Well, let the distance she ran be x. So we can write this as let the distance in kilometers that she ran be x. Now, the distance walked is also an unknown. So let's see if there's a relationship or connection between the distances. Let's look for another reference to distance in the question. Aha! The total distance is 6 kilometers. Now, the distance that she ran plus the distance that she walked is equal to 6. Now, if the distance that she ran is x, what is the distance that she walked? Do you see that this is similar to the example we did in a previous lesson? We set up a table to calculate the values. Let's do that now. Here we have our table. Remember that the total distance is 6 kilometers. So if the number of kilometers that Maria runs is 1 kilometer, the number of kilometers that she walks should be 6 minus 1, or 5 kilometers. If the number of kilometers that she ran is 2 kilometers, then the number of kilometers that she walks should be 6 minus 2. Now, if the number of kilometers that she ran was x, the number of kilometers that she walked should be 6 minus x. Now we can use this information and our knowledge of how long it took her to reach the station to set up an equation in x. With the help of this formula, speed equals distance over time, we can write time equals distance over speed. We know it took Maria 48 minutes to get to the station. Now it is tempting for us to say that 48 minutes is equal to distance divided by speed. Would this be correct? Let's analyze the information carefully. We know that Maria walks and then she runs. So in actual fact, we know that this is wrong. And instead, it would be correct to say 48 minutes is equal to the time taken walking plus the time taken running. Now to calculate these, we need to go back to our formulae. We know that time is calculated by finding the distance divided by the speed. Now, if we look at our equation, we can substitute these two parts with our formulae. We get 48 minutes is equal to the distance walking divided by the speed walking plus the distance running divided by the speed running. We already know our distances, so we can substitute these in. Do you remember what the distances are? Let's go back to our table. We know that the number of kilometers that Maria ran was x. We also know that the number of kilometers that Maria walked is 6 minus x. Let's substitute these values into our equation. We know that she walked 6 minus x and she ran x kilometers. Now let's substitute the speeds into this equation. Let's go back to the question. Maria walks at 5 kilometers per hour and runs at 10 kilometers per hour. Do you see a potential problem with this information? I hope you notice that one set of information refers to minutes and the other set refers to hours. We must always make sure that we work with the same measurements of time. Now we could choose to either work with hours or minutes. Because there are two references to kilometers per hour, here and here, I am going to convert the minutes to hours as well. So these 48 minutes needs to be written as a part or a fraction of an hour. Now there are 60 minutes in an hour, so we can write 48 minutes is equal to 48 divided by 60, and that would convert to an hour. Now we've got to simplify this fraction. We've got to think, what is the biggest number that can divide equally into 48 and 60? 12 is the biggest number. So we know that 12 goes into 48 4 times, and we know that 12 goes into 60 5 times. So we know that 48 minutes converts to 4/5 of an hour. But back to our equation. We know the reference to time here is 4/5 of an hour. Let's rewrite this information into our equation. 4/5 is equal to 6 minus x divided by the speed walking plus x divided by the speed running. Now we know these values already, so let's substitute them. The speed walking is 5 kilometers per hour. The speed running is 10 kilometers per hour. Let's just rewrite 4/5. Now to make our calculations easier, we always try to find the lowest or smallest common multiple in the denominator. This is also known as the lowest common denominator, or LCD. We know that the lowest number that 5 and 10 can both divide into is 10. So this means that our LCD is 10. Remember the scale? We need to keep the equation balanced. So whatever we do to one term, we need to do to all the terms. In our case, we're going to be multiplying by the lowest common denominator, which is 10. We will multiply every term by 10 so that we can get rid of the denominators. Let's have a look. We are working with fractions, which means that when I'm multiplying, I need to multiply by 10 divided by 1. I get 6 minus x over 5 multiplied by 10 divided by 1 plus x divided by 10 multiplied by 10 over 1. Now we can cancel and solve our equation. 5 divides into 5 once. 5 goes into 10 2 times. 5 goes into 5 once. 5 goes into 10 2 times. 10 goes into 10 once. 10 goes into 10 once. This simplifies to 4 times 2 is equal to 6 minus x in brackets multiplied by 2 plus x. 4 times 2 is 8 is equal to, now this whole bracket here, both the terms in the bracket is multiplied by 2. 6 times 2 gives me 12, minus x times 2 gives me minus 2x, and I have the plus x. Now all that's left for me to do is add up the like terms. So I got 8 is equal to 12, minus 2x plus x gives me minus x. Now I will subtract 12 from both sides of the equation. So I get 8 minus 12 is equal to 12 minus 12 minus x. This simplifies to minus 4 is equal to minus x. Now our question was to solve for x, so I need to divide both sides by -1, and I end up with 4 is equal to x. As always, we need to check our answer. In our table, we know that x represented the number of kilometers that Maria ran. We just found x to be equal to 4. This means that the number of kilometers that Maria walked is 6 minus 4, which is equal to 2. Now let's check if this is true. We know that she walks 2 kilometers at 5 kilometers per hour. So using our formula, time is equal to distance divided by speed, we know that the time she spent walking is equal to 2 kilometers divided by 5 kilometers per hour. We also know that the time she spent running is equal to the 4 from before, 4 kilometers divided by 10 kilometers per hour. Now if we look at the numerator and the denominator, we see that we can divide by 2. 2 goes into 4 twice. 2 goes into 10 5 times. So the time she spent running is 2/5 of an hour. Let's write this. The total time is equal to the 2/5 she spent walking and the 2/5 of an hour she spent running. This is equal to 2/5 plus 2/5, which gives me a total of 4/5. Now, we know that the total time is 4/5 of an hour. This is great because we originally said that 4/5 of an hour works out to 48 minutes. Let's summarize the main principles of what we learned in today's lesson. Work out what values you are looking for. Use an unknown such as x to represent the value you are looking for. Make sure that the units of measurement used are all the same. For example, convert minutes to hours. When working with fractions, find the lowest common denominator, or LCD. Multiply each term by the LCD. Now here is a task for you to complete. Solve for y. Y plus 2 divided by 4 minus y minus 6 divided by 3 is equal to 1 divided by 2. Until the next lesson, goodbye.